In this lesson, we will study about errors, residuals, and R-square, which is a goodness of fit measure. That is, you have trained your linear regression model and you get equation of a line. So how good that line is to your actual data. So that we will measure using R-square. So let's see, this is our original model where we had selected three independent variables: price, advertisement expenditure, and promotional expenditure for determining the unit sales. So for this chapter, for the purpose of understanding of residuals, we will ignore two of these variables. We had already ignored a lot of variables when we made the assumption that sales only depend on price, advertisement expenditure, and promotional expenditure. So in this lesson, we will ignore two more of those important factors and we will just consider one independent variable. And the concept of residuals is that you will get some prediction based on these beta 0, beta 1. You can predict sales on a new input price, and whatever is the difference, sales, actual sales minus predicted sales, this is called residuals. You may also see error used in place of residuals in some places. So if we plot our data of unit sales versus price, this is the scatter plot, and you will see that there is some downward kind of trend here, and this x-axis denotes the price. So as price is increasing, you see that unit sales is decreasing. And this is quite natural also, because if you are increasing the price of some item, keeping other factors constant, the unit sales is likely to go down. So from here we can guess that this beta 1 has to be negative. And we had also seen this while we had estimated the parameters of our model. But if we ignore the other factors, this beta 1 will change and it will not be the same as in the presence of other factors like advertisement or promotional expenditures, but still it's negative. And this intercept, so when price is 0, what would be the sales? That is the intercept, and that is positive. So let's calculate first these values in our Excel sheet. We will also calculate the same values using Python code also for those of you who are using Python for this. First, we will look at the Excel. So I have got rid of the extra columns. So this is just one independent variable, and this is the dependent variable or unit sales. So what we will do, we will use the same linear estimation, but we will make some changes to it. So here the y is from C2 to C25, and in this case just one x is there, one column of x, so it's B2 to B25. And then you see B calculated normally, this is for that beta 0 or intercept, so we will leave it as it is. And the next is return additional regression statistics. So by default it's false and it just return only the beta coefficients, but here we will make it true. Then you see that we get additional values. So if you remember, this was our beta 0 and this is our beta 1. So you see this beta 1, so our prediction was beta 0 plus beta 1 times price. And you see beta 1 is negative, so that downward curve is justified here. So this row is for beta. We will see what are other rows later, but one row we will be interested, one cell that we will be interested in will be this. But first let's calculate the value of estimation or predicted sales using the coefficient that we just calculated, equal to Beta 0 is this one plus beta 1 times price. So we get some prediction. You see it's not exactly equal to unit sales, but close enough. And we will do this for all of these. But before that, let's fix this coefficients. And G8 is this one, and F8. We also need to fix this. Only this B2 will be variable. And let's drag it. So these are the different predicted values. Now we will calculate our residuals. So residuals are actual unit sales minus predicted unit sales. So here the positive value denotes that we have under-predicted our sales, and negative means that we have over-predicted our sales. So this is our model. So this is the beta 1 and this is beta 0. And you can see this straight line denotes this equation of the line, which is our model. Our model is linear, so you can see a line here. Some values, these dots denote the actual sales values. Some values are above the line, some values are below the line. And the residuals are these values. So this is a positive residual because actual minus predicted at this price will be this. And the values below this are negative residuals. So big residuals are bad things because our model is far from reality. Smaller is good. Now let's see a measure of this, which is already printed here. So this cell is called R square. So it is also written as this capital R square or small r square, and it's read as R square. And this is a measure of how good your model is able to estimate the variance in the unit sales or the predicted value. So in this case, it's 0.5688. So this is fraction. So it can be any value between 0 and 1. So here 0.568 means that it's roughly able to estimate 57% of variance in your predicted sales values. Rest 43% it's not able to predict. So the closer it is the R square value to 1, the better is the estimation. So if you add other input variables like price, and if you add advertisement expenditure and promotional expenditure, this value is likely to go up since your model will be predicting much better in presence of other important factors. Now let's see the code in Python. So this was our earlier Python code where we imported linear regression from scikit-learn.linear model. We read the CSV file into a data frame. We picked the first three columns, price, advertisement expenditure, and promotional expenditure, as our independent variables, and y, which was the number of unit sales, as the dependent variable. Then we fit a linear regression model using these input values and the y values, and then we printed the intercept, that is beta 0, and the coefficients beta 1, beta 2, and beta 3. So we need to modify it slightly. First is that we have Excel file instead of CSV. You can rename your file to CSV if you like, but let's explore the other functionalities, which is pandas.read Excel. So it's very similar to read CSV, and our Excel sheet's name is fan sales _2. So this doesn't make a huge difference. And in our case, we have just one input, which is the price, and the next column is unit sales. We will do fit exactly the same way, and then we will calculate the R square value. So for this, we need to import sklearn dot matrix R2 score, and then first we need a predicted Y value. So we will predict it using the same linear regression model. So for this, we have a function called model.predict, and here we will pass the same x. So if we compare it with our Excel, and then we will calculate the R square, and we will compare whether it is same as this or not. So we have the Y prediction now, so we can calculate the R square. And just one heads up information, this is also called coefficient of determination, the R square value. And we should make sure that we give the ordering right. First is the actual Y, and the next is predicted Y. Next, let's run this. So it prints intercept 82514, and our Excel sheet is 82514, then minus 945, which is same as here, minus 945, and coefficient of determination is also same, which is 0.5688. So both ways we are getting the same values.